to another episode of Maths in an Empty Classroom with me, Mr. Southern. This is part one of the lesson on projectiles, and in this lesson I'm going to be looking at horizontal projections. So here we have first example. A ball is thrown horizontally, hits the ground 12 metres from the thrower 0.62 seconds later. By modelling the ball as a particle and ignoring resistive forces, being asked to calculate the speed of projection, the height of projection, and the speed and direction of the ball as it hits the ground. So just to highlight a couple of key things to start off with. It's been projected horizontally. It travels 12 metres from the thrower. Now that is a horizontal distance from the thrower, 0.62 seconds later. So I'm just going to start with a diagram of what this would look like. So the particle is being projected horizontally, like so. So I'm going to draw in an arrow there, and I'm going to label that U for the initial velocity. And then what's going to happen with this projectile is that it is going to fall like so until it hits the ground. And we know from the information given in the question that the distance between those 2 points is 12 metres, and that this point here is t equals 0.62 seconds. Now, a couple of factors that we consider when we're modelling projectiles. We need to consider both the horizontal and the vertical component of velocity. Now, the horizontal component of velocity, which is this bit here, we always say is constant. We assume that in the horizontal plane, that way, that the velocity isn't changing. But the velocity is changing in the vertical direction, and that is due to acceleration due to gravity, which in maths is 9.8 metres per second. Okay. So what I'm going to do now, and this is how I suggest you approach all projectile questions, is consider what is happening horizontally and what is happening vertically. And I'm actually going to split the page in two and do horizontally on the left and vertically on the right. And this just helps you to keep track of what you're doing. And then what I'm going to do is I'm just going to use the subscript. I'm going to use X for horizontal, and I'm going to use Y for vertical. So our initial velocity in the horizontal direction, at the moment we don't know. We know that the displacement S in the X direction horizontally is 12. We know that T is 0.62. And because we are saying that this is constant, the acceleration in the horizontal direction is 0. That's going to be important later on when we come to do some calculations. In the vertical direction, we have our initial velocity in the Y direction that we don't know. We have our acceleration in the Y direction, which I'm going to write as negative 9.8. And again, we know that T equals 0.62. Right. So look at what we've been asked to find. We've been asked to find the speed of projection, which is this value U, which is just the same as Ux, the height of projection, and then the speed of projection, speed and direction of the ball as it hits the ground. So the first thing I'm going to do is I'm going to work horizontally, and I'm going to use the formula, the equation of motion, S equals ut plus a half at squared. I'm going to do that horizontally. Now, the displacement S in the horizontal direction is 12 metres. I don't know U, so I'm going to put Ux. I know that T is 0.62 plus a half A, which is 0, T squared. And what this is going to simplify to here is 12 equals 0.62 Ux. Now this is important because the horizontal distance travelled is equal to the time multiplied by the horizontal velocity. So it's speed, distance, time. You would be used to, from GCSE, saying speed equals distance over time. That really should be average speed. But in this case, because the speed doesn't change, we can just say that the distance is time multiplied by velocity. So we can say that Ux, which is what we're trying to find, the speed of projection, is equal to 12 over 0.62. which comes out as 600 over 31. Which to three significant figures is 19.4. But I'm just going to put that in brackets because I'm going to be using the exact value of that for my subsequent calculations. Right, let's just split the screen at this point. Because now I'm going to work with what I know vertically. So we're looking for the vertical distance travelled, aren't we? We're looking for the height. Yes, we're looking for the height of projection, so the vertical distance travelled. So what we can do is, again, we can use S. I always do that. Equals UT plus a half AT squared again. I'm just going to correct something that I said earlier on. I said we didn't know the initial velocity in the vertical direction. We do. It's 0. Because the initial projection is purely horizontal, we say that the vertical component of the velocity is 0 because it's only moving horizontally at the point of projection. So we can use uy equals 0 here. So S, which is what we're trying to find out, is equal to ut, so that's 0 multiplied by 0.62, plus a half acceleration due to gravity, which is negative 9.8, and then t squared, and t is 0.62. So I can stick that all into the calculator, and I get negative 1.88356. Now let's just think about that answer. Are we happy with it coming out as negative? Well, yes, we should be, because the point that we've now found is below the initial starting point. So what we've calculated now is that this distance, this vertical height here, from which the ball was initially projected, is that 1.88 metres, and it's come out negative because it's below the point of projection. Okay. So that our solution to part B is that the height of projection was 1.88 metres to three significant figures. Okay, part C is asking us for the speed and direction of the ball as it hits the ground. So we need to know the velocity here, but we need to know it in terms of a horizontal velocity, and we also need to know a vertical velocity as well. So I'm going to stick on the right hand side of my board because I'm still working vertically, part C, and I need to know the velocity vertically. So I'm going to use V equals U plus AT. Now referring back to my vertical information here, velocity Y is what I'm trying to find. My initial velocity vertically was 0. My acceleration was negative 9.8 because it's due to gravity, and T is 0.62. So therefore, my vertical component of velocity is negative 6.076. And again, let's just think about why that's happened. Well, the reason that's happened is that at this point here, where it hits the ground, it is travelling in this direction here. So this is our velocity now. And what we have is a horizontal component and a vertical component which is going downwards because of the direction the particle is taking. So because I've been asked for speed and direction, I'm going to have to work this out. I'm going to have to crack out a bit of Pythagoras on this to work this out. So what I'm going to do, let's get the right angle triangle going on. There we go. This is the velocity that I'm trying to find out. And it has two components. It has the vertical component, which is negative 6.076. I'm going to just label it as 6.076 because I'm just going to use it to find the magnitude of V. And now the horizontal component, remember in horizontal direction the speed isn't changing, so this 600 over 31 is still the horizontal component of velocity. So what I'm going to do is crack out Pythagoras to find out that velocity, and then use right angle trig to find theta. Right. So V squared is going to equal 600 over 31 squared plus 6.76 squared. And then we're going to square root that to get v to be 20.286. So I'll round that to 20.3 meters per second to 3 significant figures. And then this angle here, I'm going to use normal right angle trigonometry. So I'm going to say that tan theta is equal to 6.076 over 600 over 31. And then inverse tan, make sure you're in degrees, to get that theta equals 17.4 degrees to 3 significant figures. Now it is worth noting that that is below the horizontal because of the direction of travel of the particle. So I'll just jot as part of my solution there that it's below the horizontal. Okay, so there we go. So key things to consider then. Velocity horizontally is constant, velocity vertically is affected due to gravity, so A is negative 9.8, and then just think about what's going on horizontally, what's going on vertically. Two sides of the page, split it, you'll be on to the winner. I'll see you in the next video.